Hey folks, welcome to 0-8. That's chapter 0, lesson 8. It's before chapter 1. It's chapter 0, lesson 8, solving systems of linear equations. If we have two equations and they're both linear and two variables, they're called 2x2 systems of linear equations. We can solve them three ways: graphing, substitution, elimination. Now, graphing is geometric. Substitution and elimination are algebraic approaches. You need to know all three, right? First, we have a system of equations here, y equals negative x plus 2 and y equals negative 1/2 x plus 1. All right, let's start by graphing, let's see, y is equal to negative x plus 2. Do you know what the slope is? The slope is negative 1, which is the same as negative 1 over 1. All right, do you know what the y-intercept is? The y-intercept is 2. So I come over here and I graph. Excuse me, I'll try that different color. Point at 0, 2, that's the y-intercept, where the graph will intercept the y-axis. And then I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. See, and this creates this line here. And I will attempt to draw it. Not the best line, not the worst line. All right. Now, let me get out my eraser here. Just clean this up real quick. Our second equation, we'll do blue over here, is y equals negative 1/2 x plus 1. Y is equal to negative 1/2 x plus 1. Well, what's the slope? The slope is negative 1/2. And what's the y-intercept? 1. All right. So I'm going to come over here to 1, 0, 1. That's my y-intercept. And then I'm going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Right. So let's see if I can graph this line here. Try best we can. Okay. Here's the thing. We have the two lines, two graphs. The lines are graphs, right? And they intersect where? They intersect at a particular point. What point is that? This point right here, which is the ordered pair. 2, 0. It's the ordered pair 2, 0. So we could say 2, 0 is the solution to this system of equations. Why? Because it is the intersection point of the two graphs, the two lines. All right. Notice this is only going to work if the lines are such that they're going to land right on an ordered pair, so it's easy to identify. They're kind of toy problems that way. Otherwise, this would be a fairly imprecise way of finding a solution set. Second method is much more precise. It's algebraic, and it is solving a system by elimination. Okay, you notice you have two equations. Each has two variables. It's a 2x2 linear system. We have to use substitution. Well, what could I plug into the first equation to eliminate the second equation? That's what I got to ask myself. Well, it'd be great if I could rewrite this equation explicit for x. So if I do that, it's x is equal to 8 minus 2y. Like, well, why did you do that? Well, now I can go ahead and take this x and plug it in right there for that x. Here, let's see what happens. You get negative 5. Instead of x, I'm going to put in 8 minus 2y plus 3y equals 12. Okay, what have I done? I've taken a system of two equations and two variables, made it into one equation in one variable, which I can solve. So I get negative 40 plus 10y plus 3y is equal to 12, meaning negative 40 plus 13y equals 12. Bring the 40 to the other side to get 13y is equal to 52, or y is equal to 4. All right, now how am I going to solve for x? No problem. I'm just going to come over and plug in y equals 4 into either of the two equations. Let's plug into the second equation, okay? X plus 2 times 4 equals 8. Therefore, x plus 8 equals 8, or x equals 0. So what is my ordered pair that solves this system? 0, 4. 0, 4. All right, no problem. That is my solution to my system of equations. Last method here is method of elimination. Okay. The goal is to eliminate a variable, right? We have two equations and two variables. If we can get down to one equation and one variable, we can solve it. You can't solve equations in two variables. You can solve them in one variable explicitly. All right, well, this one is quite easy to solve, isn't it? What if I just take row 1 plus row 2? What do I mean by row? The first equation is called row 1. The second equation is called row 2. If I add them together, what happens? I don't know. Let's find out. What's negative 3x plus 3x? 0. What's y plus 2y? 3y. What's 7 plus 2? 9. Do you see what happened? I had two equations in two variables. Now I have one equation in one variable, which I can solve. So let's keep going with that. 3y equals 9 becomes y equals 3. Now I plug the y equals 3 back into either equation. Looking at the second one. 3x plus 2 times y, which is 3, equals 2. 3x plus 6 equals 2. 3x equals negative 4. Therefore, x is equals negative 4/3. All right, so we got x is equal to negative 4/3. Therefore, what's my ordered pair? Negative 4/3, comma 3. That is the ordered pair that solves this system of equations using elimination. Notice in elimination, we actually use elimination and substitution. First, use elimination to kill a variable, right? And then once we solve for y, we use what's called back substitution to solve for x. That's it.